Hey everybody, and welcome back to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Now, before we go any further, I want to make sure that you click like and subscribe and the notification bell and all the other things you have to do to make sure you don't miss an episode. These builds are done sequentially. They're done with little pieces that we're assembling as we go along, and so if you miss out on a week, it's going to be hard to catch up. I want to make sure you don't have that experience, and so I want to make sure you don't miss any episodes. So let's talk a little bit about what we've done this season, just to kind of recap and make sure we're all on the same page. We started by learning about Docker, and we realized that we could put applications inside containers to make it very easy for them to start up and shut down. And easy to control the environment and make sure that everything stays neatly packaged and eliminate the problem where it works on my machine but it doesn't work on yours. After we learned a little bit about Docker, we decided to use it to create a Mongo database. So we put Mongo inside of a Docker container and started it up. And that build had persistent storage, which we had to make external to the container so that the container would not lose all of its memory when it shuts down and restarts. Then we built a Flask API and put it in a separate container and spun the two up together using Docker Compose. This is really valuable because it gives us an interface for our Python code, our front-end application that we haven't yet talked about, to connect to the database very easily. We write database code in one place in the API, and then we allow the app to consume it. After doing that, we decided to use test-driven development as a way to start our Python application build. And so the application that we selected to build is the game Hangman. And we needed a way to start building the Hangman state machine in Python. But we wanted to start from the idea of writing tests. And so we used these tests as a way to explicitly declare what it is that our application should do and how it should behave. And once we wrote the tests, of course, we didn't have any code that could pass them, and so we had to write the code of the application in order to pass the tests. And it gave us a very easy milestone system to look for. Once I know that I have 5 tests in my suite, and I know that those tests define all the requirements of my game, then I can simply write code until I satisfy those tests, and now I should have a fairly working product. So we built that way just to experiment with it and see how it worked. I hope you really enjoyed that episode. That's one of my favorites, just the ability to start with the testing cycle before you even write your first line of actual application code. After that, we wanted to make sure that our tests were run on a regular basis, and so we introduced GitHub Actions as a way to automate that process. So as a developer, I can simply write my code and I can push it into GitHub, and GitHub will know to go spin up the tests and make sure they pass before it allows me to merge my code into the completed product. After that, it was time to start building our front-end graphical interface. And so we experimented with tkinter, which is a Python library, a framework for building graphical apps. So we fiddled around with the idea of building a window and putting components into it, so you have your text boxes and your buttons and things like that, so that we could actually interact with the game. And then last week, we decided we were going to add in some security scanning. So we introduced Sneak as a product, which is a way to scan your software for vulnerabilities. But more than just the code you've written, it actually scans through any of the library dependencies that you've called and makes sure that those are safe and secure to use, and gives you feedback on your software supply chain. So kind of digging into the enterprise software development world there a little bit, we want to make sure that even the code that we aren't writing, the things we're borrowing from other people, are safe and secure and useful without introducing a lot of risk. So today's topic, I think I want to pick out observability as the thing we're going to talk about. This is not something that programmers typically think of first when they start building an application. They usually think about it when they start to hit the bug reports and the outage tickets and all of those kinds of things that happen once you've released your code to production, and people start complaining about latency and we don't have any way to tell what's going on inside the code, and somebody goes, oh, we should probably build some monitoring to see how this works. And so that's what we're going to talk about today, hopefully a little bit sooner in the process than those sort of oh no moments that happen later on. So why is it that metrics are so important? We've talked about that a little bit already, but there are some other considerations you might want to think about. For instance, load testing. If you take your application and push it to see what happens when 100 people are using it, or 1,000 people are using it, or 10,000. And load testing can even sort of become stress testing. They're sort of two distinct things. You want to see how it behaves under a normal expected sort of load, and then you also want to sort of push it to the red line to see where exactly things start to fall apart and what kind of weird behaviors emerge when it starts to. But both of those things rely on us having good metrics in place, because if you start throwing 1,000 users at your application simultaneously, you can spin that up very easily with some automation. But you can't necessarily tell what's going on in the app without being able to put those metrics in place first. And so that's why we want to get those in there as fast as we can, as soon as we can, so that we have them ready to use as we start to experiment with more and more people using our app. So today we're going to use a couple of free products to start providing metrics to be able to see how our app is behaving. These products are called Prometheus and Grafana. They're both open source projects. They're freely available, like I said, but they are extremely valuable, particularly in the case where you're using Docker containers for things, because both applications are very much designed to be able to spin up easily in containers, and they're very easy to add to an application system if you're already doing Docker Compose work. And so that's what we're going to see today. Let's see if we can take a look at some code and see how things shake out there. So here you see our Docker Compose file. We've looked at this before. There's nothing new currently on the screen, but I wanted to show you just so you have some context as to where we're going to be working today. And so the thing we're going to look at is adding a few new containers. So these are the containers we're going to add to our system. Docker Compose makes this very easy to spin up together. You just define the new containers that are needed, and they become part of the ecosystem right away. And this is one of the really valuable things about Prometheus and Grafana in particular, that they're pre-packaged in a way that makes it very easy to spin up the container and just kind of make it work. So really light lift to add them to your application, which is the way you want your monitoring and metric systems to be. They shouldn't be heavy burdens on the programmer because you want to encourage them to use it. So you don't want them to have to struggle through it. It's much easier if you can just sort of toss things out there and they just work. So let's take a look at the three containers: Prometheus, Grafana, and then a Mongo exporter. So the Mongo exporter is used to extract directly from the database. And it gives a way to gather those metrics into Prometheus very easily with prepackaged code. So I don't even have to do anything to configure that container. I just spin it up and I tell it where my Mongo container is, and it just goes. But then we have Prometheus and Grafana that we're going to control. Prometheus is actually managed from a YAML file, so we'll take a look at that in just a moment, and it'll run on port 9090 by default. Of course, you can remap that if you like, but out of the box, that's what you're going to get. Grafana is a visualization tool. So it's designed to take the metrics that Prometheus has gathered and organized and use them to do visualizations, to make little graphs and charts and dashboards and things like that out of. And so it runs by default on port 3000. Of course, something also you could change, and it depends on Prometheus. And so once you have Prometheus spun up and you have the Mongo exporter that's waiting on the Mongo database to start, and Grafana is running and depending on Prometheus to start, you're now ready to get started. Okay, but there is the one matter of the YAML file. So let's go take a look at our Prometheus YAML. Here you can see this is all the configuration that I have to do for Hangman, and it's ready to roll. So there is a job named Flask API, and it's going to use the metrics path or the metrics endpoint from our Flask API. Now, that doesn't exist yet for you because it's something that we're going to have to write next. But it's very simple that you have one extra endpoint that you add to your API, and now it's ready to roll. And the target is Hangman API. So if you remember from my Docker Compose container, Hangman API is the name of my API container, and it's running on port 5001, which is how we specified our thing here. So those would be the only real changes you have to make to that part. There's also a Mongo job that's gathering database metrics, and they're going to come from the MongoDB exporter, which has a metrics API endpoint ready to go already. So we don't even have to do anything except drop this in here. We tell it that the Mongo exporter running on 92.16 is down here, and the port does not show up in this list, but that's the default port for the exporter that it's going to run on 92.16. And so this configuration now tells Prometheus everything it needs to know about our application. Now you might be asking, why is it that we're not actually doing any monitoring of the front-end application? Well, in this case, it doesn't necessarily make a whole lot of sense to monitor the front-end application because there's not really any processing happening at that point. Now, I'm sure you could argue if you wanted to really get down to it, yes, we should have metrics on the front end. But for the purposes of today's work, I figured showing how to connect these things to the API was probably more valuable overall. And you can apply those same thoughts to the way that the front-end container would be instrumented as well. So the next thing we're going to do is go look at this metrics endpoint that we have to create in our API. So as you can see here, I've added Prometheus client, and I've had to grab several different things that are being imported for use. And I don't know why my editor's doing this right now, but for some reason, even though I'm in my virtual environment, you can see down here on my terminal, for some reason it doesn't understand that Prometheus client has been installed. That's a simple pip install, by the way. And I haven't been able to get it to stop being like this about it. But it works, so I can have confidence in that at least. I was able to get it to start up and work. Now, once I've added Prometheus client there, the next thing I have to do is declare the metrics that I want to use. And so you can see right here I have a request count and a request latency. The request count is a simple counter, and it's going to give me all of the Flask app requests, and it's just going to total them up. As I make API calls, they'll get added to this list. The latency is going to detect the number of seconds that it takes to run a given request. And in this case, I'm just doing it generically for all. You could be much more specific about this, and you could start to capture multiple types of metrics. I wanted to keep my example short and sweet, make it simple for you to see. This is obviously not the most valuable way to monitor my metrics by smashing everything into just 2 data points. But this should give you enough to go on where you could start to extrapolate from here. So we had back in our Prometheus YAML, we had a metrics endpoint that was showing up, and we didn't have that yet. So that's the next thing we have to build. We make a new app route called /metrics. We define it to return this generate latest. Now, generate latest is a method that I actually pulled in from the Prometheus client. So I don't even have to know how that works or do anything about it, but the short version is it's going to take all of the metrics items that are gathered in this counter in the histogram in this case, and it's going to package those up for Prometheus and send them over to say, here are all of the metrics that I'm passing. And if you look back at the Prometheus YAML, we have a scrape interval of 15 seconds. So every 15 seconds, a request is going to get made to this metrics endpoint, and it should be sending the latest metrics back. Now, the next thing we're going to look at is that on my various app routes, I've added my metrics to make them work. So there's an increment statement that I put on the request count for every time an API method gets called. So when you call /getAll, it's going to increment request count. There's a new request made of the API. Then there's a latency, and I do a time. And so this time method is really interesting to me. I had not seen anything like this before, but it's really powerful. It effectively works by timing everything that occurs inside of this with. So the with contains the rest of the method in this case, but I pick out the section that I want to know how long it takes, and I put that inside the with. And this request latency.time is going to give me the time that it took to run that with block. I found that to be a really intriguing sort of system there, and the way that it adds it in is just visually striking to me. I like the idea that I can just put things in a block of code, and I'm going to measure everything in that block. And so I'm not going to go through the whole rest of the API, but suffice to say, I've added these things to every route in the API. And so every different API call that you can make is going to add to these metrics, and that's what's going to get them to run. Now, another note that I have to throw in here as a side note is that we did have to make some changes to our requirements.txt. And in particular, we're adding the Prometheus client into requirements.txt. That's important because when you're ready to spin up your Docker container, it needs to be able to build the Flask API from that. And the only way that it's going to know what to do with all of this stuff is if Prometheus client is installed in the container. And so make sure that you make that update. If you miss that, you're going to have problems getting your container to start. All right, so that's all it takes to get started with these metrics, and we're actually ready with just those few changes to get our Prometheus and Grafana containers to spin up with our application. So let's take a quick look and see what it looks like when we actually run them. So I'm going to go down here to my terminal, and I'm going to do docker compose up -- build. Okay, and we can see the entire system is now starting up. You can see Mongo container is beginning. There were some notes in there. If you could see it go by, it was pretty quick about Grafana starting up. There's Prometheus. The Hangman API is up and running, so all the pieces are in place now, and we might be ready to go. Let's go over to Docker Desktop and take a look. You can actually see all of our containers are running. We got green icons over here, and everything's looking sharp. So how do we test this out? Well, all we have to do is start making some API calls. The first thing I'm going to do, though, is go on ahead and open Prometheus. I'm going to pull up the web page here so you can actually see what's going on. So I'll open Prometheus. This is on localhost port 9090, and if you put that in your browser, then Prometheus running means you're up and good to go. So now I can actually start asking this thing. Let's see if I can find Flask. That was the term I was looking for. So you can see here are the metrics that are being gathered, and we can look at the number of requests. And so I'm going to hit execute. All right. Now I'm going to go over here and I'm going to do localhost 5001. Let's call the getAll. And you can see there, I'm just calling this straight from the browser tab. So there's that appears. And what happens if I change this down to 5 minutes? Well, did I actually see the numbers go? So let's go back here and let's grab requests total, and there you see it's actually made a request. And so if I come back here and I just put in for the random, then sometime in the next minute here, there it comes. There's my second request. Let's go look at the count of latency seconds. So we've used 2 seconds of latency in our application. Not bad, but it has the ability to start gathering these metrics. And so if I hit that button again, then just a moment, it should ask me for, or it should pop up another, and there you go. We now see our third call being made. So Prometheus is gathering data. Now the next thing we're going to look at, if we go back over to Docker Desktop, is we can actually see Grafana. Now, when you spin up Grafana this way, the default is admin. As you can see, I've already done this once and remembered my password, so I'm just going to do that, and now I'm into Grafana. So here I can create a data source. I've already done this, so you can see it. Let's go look in here. So it knows that the name is Prometheus, and it knows to look at HTTP Prometheus:9090, and that connection now means that I'm going to have data available where I can start creating a dashboard. So if I come to new dashboard and I do add a visualization, I can visualize from there, and then I can do, there's tons of metrics that are already being pulled in. And so if I pull the sum of latency seconds, there we go. I can actually start to see my data appear in front of me. This is currently set to last 6 hours. Let's go to last 5 minutes, and there you get a look at it. So here in Grafana, I can start to build out a dashboard of the various metrics that I'm gathering from my application. So I might look at setting up metrics for each endpoint separately and graphing them as multiple lines on this graph, just to have different series and see if there's a certain query that's failing more than others or something like that, so that I'm able to troubleshoot more easily. But that's all it takes, and just in just a few minutes, I've been able to create a system that not only allows me to gather those metrics, but instantly turn them into graphical displays where I can start to give this to somebody on my operations team who watches the Flask API and makes sure that it's behaving properly. This becomes a really powerful communications tool between two teams. So between your dev and your ops teams, to be able to communicate about the state of the app and what's going on, and understanding the behavior of the application when it's under load. So you might be thinking, hey Blink, these examples are really small and somewhat contrived. But that's keeping in the theme of exploring these concepts in a very small space. I don't want you to worry about the deep complexity. I want you to be aware that you can get deep and complex with it, but I don't want you to feel like you have to do that with Hangman. And it wouldn't make much sense with a lot of Hangman to be able to instrument at those levels. But these are tools that you can use in other things as well. And so it's important to be able to see it in the small scale, and then over time you'll be able to apply it in the larger. So I hope that you have learned an awful lot this week. This is one of my favorite parts because it's so much about the interaction between people. And when you're gathering these metrics and being able to share them with people who aren't deeply into the weeds of your project, you can make a quick dashboard that explains the situation to someone who doesn't know your application very well, but they can start to give you information that helps you understand as a programmer how to fix a problem. So next week is going to be our season finale. We've reached the end of season 2. This has been so much fun, and I'm really grateful that I get to do this here with you each week. But we're going to finalize the season with something that I've kind of hinted at along the way that I've sort of promised was going to be there. We're going to do some AI integration. And so we're going to take our Hangman game and we're going to let a large language model provide the games that we're going to play within it. So what board? Well, I don't necessarily just want to pull one out of the database. What if I could generate them on the fly? What if the large language model could try to stump me and see what sorts of things it comes up with? So we're going to explore that and see how to plug that into our code. I hope you'll tune in next week and see what kind of fun we can have with it as we finish out season 2. I'd also like to remind you again to click like and subscribe and all that, and make sure that we're connected. Send comments in the chat. Be part of the experience. If you're building along with me, I'd love to see what it is that you've done to customize your game. Tell me a little bit about how things are going. I can't wait to see what you build. We'll see you next time.